Okay, the first topic we're going to talk about today is the idea of irrational numbers versus rational numbers. Okay, so here's what a rational number is. Any number that can be expressed as the quotient of two integers. So for example, 8 is a rational number. Why? Because 8 is 8 over 1. Okay, this is a rational number. Negative 2.5 is rational, right? Because look, this can be expressed as negative 5 divided by 2. Look. Negative 5 divided by 2, negative 2.5. You can even this, for example, is a rational number. 22 divided by 7 is sometimes used to approximate pi because it starts off the same 3.14, right? Now here's the thing, this decimal, right, it does end at some point, okay? So even this is a rational number, so any sort of any fraction like this is rational, okay? Now, square roots that are rational, okay, square root is, remember, it's like this symbol. This symbol is called a radical symbol. Okay, that's what this actual symbol is called, is a radical. But if I put a square root, and let's say I put the square root of 100, right? This is a rational number. Why? Because this just equals 10. This means what number times itself equals 100? And the answer is 10. Or the square root of 9 is rational, because what's the square root of 9? It's 3. Or the square root of 1 is rational, because what's the square root of 1? 1. 1 times 1 is 1. And let's do one more. What's the square root of 49? That would be 7. These are all rational numbers, okay? Now, an irrational number is any real number that cannot be expressed as a quotient of two integers. The most famous irrational number is pi, okay? And these numbers are non-ending, non-repeating decimals. Okay, now this non-repeating part is important because look, 6 divided by 9, look, 6 divided by 9. Now look, we know this is rational because I'm about to divide two integers. This is the quotient. This is division between two integers. This is a rational number. Look, this is a repeating decimal. This is 0.6666666 repeating, and the 6 goes on forever. The only reason the 7 appears here is because the calculator rounds it up, okay? But this is the number, like for example, look, this is a rational number, 6 over 9. This equals 0.6 repeating. That decimal repeats. Irrational numbers, the numbers don't repeat. Okay, now, here's the thing. If I do the square root, look, watch. I'm going to use the square root sign right here. I did second in this. You don't need to know this yet. Look, if I do the square root of 100, that just equals 10. Now, if I do the square root of, let's say, 15, that equals an irrational number. This decimal goes on forever. It doesn't repeat. It doesn't have a pattern, and it also doesn't end. So this is an irrational number. Any number that's not what's called a perfect square. 100 is a perfect square because it's 10 times 10. 9 is a perfect square, it's 3 times 3. 1 is 1 times 1. 49 is 7 times 7. Any number that's not a perfect square, like 50, right, or 17, or 48, right? These are not numbers that have a whole number square root. These are all irrational numbers, okay? And there's like a whole topic about what we can do and not do with irrational numbers, okay? So these are irrational. These are perfect squares. They are rational.